Hey Emily, I hope you're doing okay. I hope all is well with the whole tooth thing and everything. I hope you're doing all right. I'm going to just talk to you about some of these problems. Hopefully, this is helpful. You could let me know when we get together if this is working out or not. What I like to do is just go through each problem. Feel free to fast forward if there's a problem that you already worked through and you feel comfortable with. So let's begin. So the answer to this first one is 10, all right? And we get that by doing exactly what it says. It says if this thing is equal to k and k is 3, find x. So this is the one that we're looking for. So I like to do a quick rewrite. X minus 1 over 3 is equal to, replacing the k with 3 gives me 3. And so basically I have to solve this problem. When I want to solve problems like this and I've got this crazy denominator, I'm going to multiply both sides by a number that can gobble up or that's the greatest common factor or that can take out the denominator in a way. So when I have that, these are going to cancel out. This becomes 9. So my problem can be rewritten as x minus 1 is equal to 9. At this point, this is a pretty simple problem to solve. Add 1 to both sides, and I see that x is equal to 10. All right, let's look at this next problem. This might be something that you don't remember, right? Because I is equal to the square root of -1 is something from Algebra 2 that some people forget because it's not something you use in your everyday life. The cool thing about this though, even though this has this value, I has this value, the cool thing is you can treat I like a variable. So if I'm going to add these two complex numbers, that's what they are. If I'm going to add these two complex numbers together, I'm just going to do what I would do if this were like 7 plus some 3x plus -8 plus 9x, whatever. I'd join like terms together. So my like terms are 7 and -8. When I add those two together, I get a -1, and then 3 plus this 9i, 3i plus 9i, pardon me, is going to be 12i. And you can see that the answer is right here. So the answer is A. Let's take a look at number 3. Okay, and I'll start off by simply saying that the answer is C, 5m plus 4p. If you got that, keep moving. If not, let's talk about it. On Saturday afternoon, Armand sent M text message at each hour for 5 hours. So if that were like 3 text messages each hour for 5 hours, then that will be 5 times 3. So in this case, we don't know what M is, so we know that that's going to be 5M. And then similarly, Tyrone sending P text message each for 4 hours apiece. Like, so every hour he sends P, that's going to be 4 times P. And we're just going to add that up and get 4P. Couple things to notice: we can't bring two variables together because we don't know what those values are, especially if they're unlike variables. And also look at this answer right here, which is not the answer. Let me take the circle off of that. Can't do it, which is not the answer. What that is kind of a trick just to see if you're paying attention in a way, right? So you want to make sure and keep track of what letter refers to what problem. Let's take a look at this problem really quickly. And the answer here is B. So we've got a lot of gobbledygook to talk about, but let's try and see if we can work through the problem. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated by this equation. So really, notice this is a problem where you don't actually have to solve anything. You just got to think about what the equation means. So here's the equation. P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days that she has worked that week. So P is the number of phones left. So I would expect that over the time that she's working, she's reducing the amount of phones that she has left at the end of the week or during the week to actually fix. So it makes sense that we're subtracting, and I see 23D, so 23 times the number of days, as they told us, gives me the number of phones that she has left, and I'm subtracting that from 108. What is the meaning of 108 in this equation? So as you look through the answers, Kathy will complete the repairs within 108 days. Well, doesn't seem like days are really being coordinated with the number 108. In fact, if P is the number of phones, to mix days in here, calling this days would be like subtracting the number of phones from days to get the number of phones, which doesn't make very much sense. Looking at B, Kathy starts each week with 108 phones. That's that number. And per day, it looks like she's taking off 23. So it gives you the amount that she has left for the remaining part of the week. So that feels like it makes sense, but we could look at the other ones as well. Kathy repairs phones at a rate of 108 per hour. No, it looks like she's only doing 23 per day, right? And finally, Kathy repairs phones at a rate of 108 per day. Well, if she did 108 per day after one day, we'd get zero. Like she'd have a negative number of phones to actually work on. So it looks like B is the only one. And again, that took kind of careful reading and making sure you knew what was being asked. Let's take a look at this next problem. So we're on to the next page and we're looking at number 5. The answer to this is C. Let me get another color to show what's going on. So basically we were simplifying here, right? So what we're doing is we are going to join like terms together. X squared y is like x squared y over here. 3y squared is like the 3y squared term here. And this 5xy squared is just like this 3xy squared term. So those are like terms. We're going to join them together. But first we've got to distribute this negative through the whole thing. So this, after I do that, this will become positive. This will become negative, and this will become positive. So if I were to take off the parentheses, this is what I'd have: plus, minus, and plus. And what I'm going to do is join like terms. So when I bring this guy with this guy, because they're alike, I get 2x squared y. And if I bring this guy right here with this guy, they're exact opposites actually, and they cancel each other out. So that's gone. When I have 5x squared and a minus 3x squared, if I'm subtracting it, I'm left with plus 2xy squared. I said 2x squared, that's my bad. But since this is a positive 5 minus 3, that's what we get. Let's look at number 6. In number 6, let me give you the answer. So my answer is A, and we're going to, again, kind of analyze an equation like we did in the last problem, a couple problems ago. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age A, in years between the years of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Well, you're looking at this equation. I'm hoping that it reminds you of y equals mx plus b, right? It kind of has that vibe to it where m is the slope or the rate of increase, and b is like the starting point. So if we think about that, we see that the rate of increase here is 3, and the starting point is 28.6. So that's apparently the average age of a 2-year-old or something is what's going on here. You don't need to know all that. What you should do in a situation like this, if you can't immediately pick out that that 3 is going to really be giving us our rate of change, because that's really what the slope is, what you should simply do is take one age and another age and see what happens. So if this works for all kids from 2 or all boys from 2 to 5, throw a 2 in there, see what answer you get. So when you throw 2 in for A, h is equal to 3 times 2 plus 2.6, then throw 3 in there so you can see 1 year difference to see what is the increase. So I'm going to do that. So I'm going to do for a 2-year-old, for a 3-year-old, this is what's going to happen: 3 times 3 plus 2.6. Here I'm going to get 6 plus 2.6, which is going to give me 5. Nope, just lied to you. Sorry. Lying. 6 plus 2.6 is going to give me 8.6. Here I'm going to get 9 plus 2.6, which is going to give me 11.6. It's clear that the jump from here to here in that 1 year was 3 inches. And so that's where the 3 comes from. So whether you can see it in the equation or you need to put a number in there, do something so that you can analyze that equation. So putting a number in there made perfect sense, given the fact that we were given certain numbers that we could work with. All right, so number 7 looks like a beast, but don't be afraid. Let me give you the answer to that. Let me actually move this around. Hold on. All right, so your answer here is B. Oops, that didn't look good. Your answer there is B. And what you need to keep in mind, let me just circle it like that. What you need to keep in mind is this problem is not as ugly as it seems, but it feels ugly. So I'm going to try to make it look better. So I'm going to call this the red equation. I'm going to call this the orange one, and I shall refer to this as the green one, the green expression. So I've got these pieces here. Sometimes it's easier to look at them as blobs of things as opposed to really, getting into the detail of it. So they told us, here's this complicated formula, and what they're asking us to do is to actually solve for P, meaning get P by herself. So if I had to get P by herself, that means all this stuff over here needs to go, and it needs to go to the other side. If this were a regular problem, let's say you had M is equal to, I don't know, A times B over C times P. And I'm also going to, Let me see if I can get this done the way I want to do it. I'm also going to highlight these similarly because if you notice, everything is positioned exactly where these things are. Though they're more complicated, my A, B, and C are kind of positioned very similarly. What I would do to get out of this jam, right, is I'm going to multiply by the reciprocal. Remember the reciprocal? Let's go back, little thought bubble over here. If I have 3 over 5 times 5 over 3, everything cancels itself out and we just get 1. Well, I'm going to do something similar here. I'm going to multiply this side by the reciprocal, right? So C over AB, I'm trying to squeeze it in there, and I'm going to do the same thing, C over A times B. When I do that, I cancel out all the drama, right, that's on this side that was causing me problems, and I'm just left with P. And so basically what I'm saying is you need to multiply by the reciprocal. And so when you do that, the reciprocal of this ginormous equation, though unattractive, is actually quite simple. So let's see if which one has that. So there's the green part, and then the orange part, and then the red part. Well, this is not the reciprocal. This is exactly the same thing. But over here with the answer B, you see that the green part is at the top, and then the red parts and the orange part are in the denominator. If this doesn't make sense, please let's talk about it. I know it seems a little bit crazy, but the point is if you just take those things as big blobs and you move them around as you would if you had something like the little example we looked at before, it really does work out the same way, and everything else is just way too simple to actually be an answer. All right, let's keep moving. So the answer here is 2, and the way I did it is maybe not the way everybody else would do it. I talked to some other students about this and they weren't really feeling my explanation, but I'm going to try it out on you. So if AB is equal to 2 and then we're asked to analyze 4B over A, first of all, I really wish that the B were at the top and the A was at the bottom. Here's a little trick. If I have A over B and that's equal to 2, I could also say it's equal to 2 over 1 because 2 is 2 over 1. If two fractions are equal, their reciprocals, when I flip them, are also equal. So I can also look at this as B over A is equal to 1 over 2. Totally legit, totally fine, totally mathematically sound. Now this looks a little bit more like that, but it's B over A times 4. So I multiply it by 4, but if what I do to one side, of course, I'm going to do to the other. When I do that, 4 times a half is equal to 2, and there's my answer. The kids who did not like this explanation did something interesting. He solved for A. So he had A, okay, I'm going to write this in a different color so you can see it's a different explanation. A over B is equal to 2, and so he multiplied both sides by B in order to solve. So we got that A was equal to 2B. After that, he took it and he plugged it into the equation. So if 4B is at the top and A is at the bottom, then he's going to replace that with 2B. When he did that, those cancel and he got 2 as well. Whatever solution you like or whatever process you like is cool, but the solution is the same. Let's look at number 9. Number 9, which of the following XY coordinate pairs satisfies these two up here? There's a way to process and solve this, which is totally fine. There's a couple ways. One is elimination method, one is substitution method, the other one is graphing, and there's some other fancy other things you can do. But the reality is the answer is right here, so it makes total sense to simply plug in the pairs of numbers to see which ones work. All right, so if I plug in, remember that the first term is X and the second term is Y, and you'd have to plug it into each, and I shall give you the answer, and the answer is B. Because when you plug it into both equations, it has to work in both. When you plug 3 in for X and you plug negative 8 in for Y, it works in both equations, means it satisfies, it's true. All right, number 10. As we look at number 10, it says the function g defined above, a is a constant. So a just means it's a number, it's not a variable, it's a number. And g of 4 is equal to 8. What is the value of g of negative 4? So this is kind of weird. First of all, when you have g of something, it means whatever is in this blank goes exactly where the x term is. So g of blank is equal to a times blank squared plus 24. My time's going to be up. I'm going to continue this problem in another video. I'll talk to you soon.